Welcome to A-level chemistry. I'm going to take you through what we need to do when we come to A-level chemistry. My name is Samuel Asamoah, and I'm the head of chemistry department at New College. When you come to New College, we do A-level chemistry. And what happens? A-level chemistry is a linear system. That is, it is a 2 years, and students are required to revise all the 2 years work. At the end of your stay here with us in New College, you're going to sit for 3 exams at the end of the 2 years. And so year one, at the end of the year one, there is no external exam. But at the end of the 2 years, then you sit for your final exam. That's linear. So at the end of the 2 years, you're going to sit for 3 papers. As I said earlier on, you have paper 1, paper 2, and paper 3. 3 papers in total. Together, you'll be given 1 grade for the 3 papers. If you do want to retake any of them, that means you have to sit for all the 3 papers again. If you, at the end of the 2 years, you do not, maybe you're not interested, you don't like the grade, then you want to retake, it means you have to take all the 3 papers again. That is the linear course of chemistry and almost all the A-levels at the moment. You cannot select 1 paper and go and sit to better your grade. That is no longer allowed. What sort of careers can you do with A-level chemistry? You can go ahead and study medicine to become a doctor with chemistry, where they require A-level chemistry, a minimum of grade A, or better still, if you can get an A-star, good. Dentistry, physiotherapy, pharmacist, you can become a pharmacist doing A-level chemistry as well as one of your subjects. You can become a teacher like myself, steel production chemist, an accountant. Yes, people say, how can you be an accountant doing chemistry? Because chemistry helps you to be analytical. So some accountants are previously chemists. We have polymer chemists, we have oil industry chemists, we have food science chemistry, or you can become a food scientist studying chemistry as well, because we have food science which deals with chemistry, or food chemist in future. Pharmaceutical industry. There's a difference between a pharmacist and pharmaceutical industry. So a pharmacist is the one who dispenses the medicine, and the pharmaceutical chemist is the one who helps in synthesizing, making the medicine. Then the pharmacist will give it to the patients when they come to the hospital or the shop. Right, so at the moment, what we have here is that A-level chemistry, when we come to New College, at the end of the 2 years, you will receive all the best support you can to be able to pass successfully and go to uni to further your studies with your chemistry with us. Now, I'm going to demonstrate some few things that we do with in chemistry over here. The first one, turning water into wine. Wow, okay, so let's see what I will do with that. Okay, right, so I have my glass. Yeah, I've got my glass over here, and I've got a solution, which I'm not going to tell you at the moment. So I'll measure about 20 cm cube of that solution into my measuring cylinder. Then I've got my glass, right? So I'm adding my solution that I've measured into the glass. Wow, I've got a wine in the lab. I'm not going to drink this, don't try it, okay? Now, you know what happened? Yes, all I did was that I had sodium hydroxide, and then I had phenolphthalein indicator. So when I add 3 or 4 drops of phenolphthalein indicator into my glass, and I add sodium hydroxide to it, it turns pink. And so you see it as wine. Okay, so that's a simple way of identifying sodium hydroxide. So if you give me a solution like that, and I want to, and it's unknown, not labeled, and I want to identify it as sodium hydroxide, I'll just take a small portion, measure small into a test tube, add phenolphthalein. If it turns pink, then I know it is what? Sodium hydroxide. So my wine here is just sodium hydroxide with phenolphthalein in it. Okay. Now the next one I want to demo for you is equilibrium reaction. Equilibrium reaction, where the reaction shifts to the left and it can shift to the right as well. If I should show you back into my slide, you will see what I'm trying to refer to here. Okay, so let's look at the equilibrium reaction. Yes, so one you see there is an equilibrium reaction, cobalt and HCl that I'm going to add, but you only see chloride. So cobalt and chloride forming cobalt chloride and water. Now the cobalt, as it is pink. And if I add HCl to it, okay, it's supposed to go blue. So that's what you see. But if I add water to it, it will come back to pink. That shows you the equilibrium can shift to any side depending upon what I add. So if I add water, after setting the equilibrium, it will turn pink. If I add HCl, it will go back to blue. So the system will be shifting left and right. Let's see if I can do it in the lab, okay? Let's see how it goes. Okay, so here I have a boiling tube. I need a bigger one so that you can all see. Okay, so I got a pink solution. Yeah, a pink solution in there. You can all see it's pink now. Now I'm going to add HCl to turn it to blue. Okay, so it goes blue now. Yeah, can we see that? All right. Now I'm going to turn it back to pink. So I'm going to shift the equilibrium back to left. Okay, so I've added a bit of water. Okay, so it's going back to pink. Let's see. Okay. Okay. Yeah, it's gone back to pink now. Yeah, can you see gone back to pink? Right. Do you want it to go back to blue? Yes, I can. Shifting it back again. So add HCl. And it goes back to blue. So it goes back to blue. So I can shift it left and right, indicating that a reaction can go to left and right, provided you want it to move. Whatever you add, it will shift to the side you want it to shift. And that is exactly what I was doing with this particular reaction. It was blue, then I can take it to pink, and I can take it back to blue by adding different reagents. So reaction move, we call it reversible reaction. When you come, we're going to do some of these experiments. Now, the next one I want to demo to you, I know you're going to enjoy this one, combustion reaction. Now, let me show you this reaction also before I do the experiment. Okay, so now this reaction here that I'm going to show you, I'm going to react an alcohol, okay, with oxygen. So there on your screen, now you can see that I have ethanol reacting with oxygen to produce carbon dioxide and water. Energy is also released. And so we see a lot of energy coming out at the end of the reaction. When I scratch a match, it will give you a very big fireball. So I'm going to demonstrate that one. But once again, don't try it at home. You can only do it in the lab, okay? So combustion reaction, reacting ethanol with oxygen, producing carbon dioxide and water. Energy is released. And that energy, I will burn it. when I scratch a match, and you're going to see that as well. Okay, right? So combustion reaction. Let's demonstrate that. Right. So I've got a bottle here with ethanol in it. So I'll shake it. Yeah, so I'm just shaking it. Okay, so shake it, shaking it to warm it up more. Right. Okay. So very soon I'll stop there. Okay. Let's try it one more. See. Okay, so let's put it down a bit and then get ourselves ready for the match. Okay, good. So we're getting ourselves ready for it. Okay, so I'm going to now. That's how powerful the energy comes out. So after shaking it, it was reacting with oxygen in the container. As soon as I break the flame, that's with a big fireball coming out. So the energy that I've released is what you saw coming out. Combustion reaction. Don't do this at home, as I said. It can only be done in the lab. So don't try it at home. Okay? Right. So back in here, as I said, when you come to A level, these are some of the chemistry that you'll be doing with us over here. And a lot of practicals are done, and you enjoy the chemistry with us in New College. However, I must say that working in the lab, you must always wear your goggles. So me using it, you must have your lab coat on, because we encourage you to have that so that you can protect your dress and your eyes. Okay? There are models that we can use also to make organic compounds. And when you come around, we were going to give you some models for you to play around to be able to model hydrocarbons like methane, like propane, like butane, and so many of them. So when you come, we will use some of the models to model like methane, ethane, propane, butane, and so on and so forth. These models helps you to understand the structures that you are taught in organic chemistry. So if you are given a compound like that, you should be able to model using the model kit and be able to understand how the bonds are made or are in the reaction. Some of these cyclopentane, you can model that as well. And you can model cyclohexene. Yes? as I said, yes, chemistry is fun, but you must always take precaution. Because if you don't take precaution, you may end up harming yourself. Okay? Hope to see you coming to New College to do chemistry. That is fun, and you will enjoy it. And many of our students always go to update to uni to do a lot of professional courses, and the courses they will enjoy forever in their lives. A lot of our teachers are here who help you to make the right choice of career, and you are going to enjoy your stay here with us at New College. Thanks for listening. Please make sure you complete your form. When the time is up, come to New College and enjoy chemistry. Okay?